All right, problem number 1 is a calculator-aided problem. Here we go. People enter a line for an escalator at a rate modeled by the function r given by the equation below, where r of t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 persons per second. There are 20 people in the line at time t equals 0. Part A asks how many people enter the line for the escalator during the time interval 0 to 300. Okay, we're going to, first of all, before we decide what we're going to do with this problem, we want to look at the units to see if I can help, we can help that will help us solve the problem, sorry. How many people? So we're looking for how many people. And if I look at, they are giving us a rate, and the rate it said that is measured in people per second, and then t is measured in seconds. So I know if I'm at a rate and I want to get rid of the rate, what I'm going to have to do that is to take the integral. And so I'm going to be taking the integral, it said from 0 to 300, so my bounds are going to be 0 to 300. And I'm going to take the integral of the rate, so it's going to be r of t dt. And if I do that, and it's just between 0 and 300, so I'm actually going to be, when I use my calculator, I'll be plugging this formula into my calculator to get the answer. And then one thing I do want you to notice on the units as well, if I take the units of the inside, which is people per second, and then I multiply it by my bounds units, which would be seconds, peoples per second times seconds, the units do cancel out and just give me people, so I know that I'm in the right direction for that. So when I do that, I'm just going to use Math 9 in my calculator, and when I do that, it comes up to be just a nice even 270 people. All right, this problem would have been worth 2 points. I get 1 point for setting up my integral, and then I get 1 point for getting that correct answer. One thing on this one, you don't really want to run the risk of writing this down incorrectly, so that's why I just wrote the r of t. And I remember when I was correcting this problem, many people somehow typed this in their calculator incorrectly, so just make sure you're using the numerator-denominator button, because that will really help. Some people are ending up getting like 1 million people, which would not make sense over 300 seconds for that many people to have been in line for the escalator, so just check that as well. Okay, part B. During the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time t equals 300? Okay, so again, we're looking for how many people, which we know is going to be some sort of integral. And this one, we're going to always start with, we're going to kind of follow the pattern of our initial amount plus the number in minus the number out. Okay, and if I follow that pattern, how many people were in line to start with? And it said there were 20 people in line to start with, so we're going to start with 20. And then plus the number of people in, we actually already found that in part A. So the number of people that got in the line were 270. Okay, and then minus the number of people that got out of the line. You will notice that it did tell me that it did give me a rate for that one, which was 0.7 persons per second. So I can actually go ahead and set up an integral for that part, just like I did in part A. We're still going to be going from 0 to 300. And this time when I do that, I'm just going to use the rate of 0.7. So that's what they said was 0.7, and I'll also just stick a dt on it. So that's the setup that I would have. And then the answer that I'm going to get when I do that is 80. All right, I would get 1 point if I considered this rate out, and then I'm going to get 1 point for the correct answer. Okay, for part C, for time greater than 300, so we're switching up the time here. What is the first time t that there are no people in line for the escalator? So this time we want no people in line for the escalator. So what I did, first of all, we know at time t equals 300, there are 80 people in line, okay? And then we know that after time 300, no people are getting into line. There are only people getting out of line. So I'm still going to actually follow that same pattern. So we want the initial plus people that are getting in line plus people that are getting out of line. So initially at time 300, we had 80 people. Nobody's getting in the line, so it's just going to be plus 0. And then minus, there are people getting out of the line, so just like we did on the last problem. But this time it's going to start with 300 people. And I don't know when we're going to stop, so I'm just going to put a t up here. My rate is 0.7 dt, but I want there to be no people, so I would like this to equal 0. So then what I'm going to do from here, I'm going to go ahead and calculate this integral. We do get to use our calculator for this, but it's not going to help me because the t's there. So the antiderivative of 0.7 would be 0.7t. I'm going to be evaluating at t and 300. So when I do that, I'm going to be getting 0.7t minus 0.7 times 300. And that is going to give me 0.7t minus, that will be minus 210. But please notice there's a minus sign that's going to get hooked to both of those. So when I go to rewrite this, I'm going to have 80 minus 0.7t plus 210, and I'm going to set that equal to 0. And then from here, I'll add the 80 and the 210. I'll get 290 minus 0.7t is equal to 0. I will subtract 290 from both sides, so I'm going to get negative 0.7t is equal to negative 290. And then if I divide both sides by negative 0.7, I will get 414.286 seconds. So I did go out 3 places. Please notice on that. All right, that part would have been worth 1 point. Wow, all that work for 1 point. Oh well. All righty. Part D, for 0 to 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. So we want to find the time t, and then we also want to find the number of people. So there are 2 parts that are going to be going on in this problem. Okay, keyword on this one, we want to know at what time is the number of people in line a minimum. And since there's an interval given, we're looking for an absolute minimum. And I know minimums occur either at the endpoints or at the critical numbers. So first of all, I need a formula to plug in to see what's going on. So I'm just going to call this the amount of people. So A of t, and I'm going to use my initial plus in minus out function here. I know there are 20 people in line to start with. I'm going to be going from 0, and I don't know when I'm going to stop. It's going to be somewhere between 0 and 300, so I'm just going to put an X up there or a T or something like that. And then, actually, I think I'll put an X just so I have different variables here. And then this is going to be R of t minus, then the people going out is going to be somewhere between 0 and X, and my rate is going to be 0.7 dt. And I want that to be a minimum. So if I am looking for critical numbers, I need to find the derivative of this. So my derivative is going to be the derivative of 20 is 0. The derivative of an integral is just r of t, and then minus the derivative of an integral, again, is just the 0.7, okay? So I would like to find when is that going to, where do I have a critical number? So I'm going to have r of t minus 0.7 is equal to 0. Which means I want to know when does r of t equal 0.7. So what I would do, we already have r of t in our calculator is y1. I'm going to put this in as y2. And then when I do that, I am going to be looking for the point of intersection. Okay, so when you put both of those in your calculator, and you can go ahead and take a minute and do that, or maybe you already did. I did have to adjust the window to be, this was my x min and 300 was my x max. And when I did that, my point of intersection turned out to be, actually I had 2 of them, 33.013, and then I also had 166.575. So I found my critical values. Now to find an absolute minimum, I need to find A of 0. I need to find A of 300. I need to find A of 33.013, and I need to find A of 166.575. Okay, and when it says to justify your answer, what I'm doing right now is actually justifying my answer. All right, A of 0 is how many people would be in line at time 0, which they already told me was 20. A of 300, we already found out in part A, which was, actually found that out in part B, which was 80. A of 33.013, we're going to go back to that amount formula. So we're going to have 20 plus 0 to 33.013 r of t minus 0 to 33.013.7. And that, if you were type that in your calculator, you should end up getting 3.803. And then for the 166.575, we're going to do the same thing. So I'll have 20 plus 0 to 166.575 R of t minus 0 to 166.575.7. And when you type that all in your calculator, you will get 158.070. Okay, so the question asks, at what time is the number of people in line a minimum? Well, I notice my answers are 20, 80, 3.803, and 158.070. So I can see a minimum occurs here, and it says at what time is the line people at a minimum? So my answer is going to be at t equals 33.013. Number of people in line is at a minimum. And then to the nearest whole number here, find the number of people in line at this time. So number of people in line, there were 3.803, rounded to the nearest whole number would be 4. All right, this part was worth 4 points. If somewhere in the problem I found that I was setting up the critical number, so I took the derivative and set it equal to 0, that would have been worth 1 point. If I identified the 33.013 as a candidate, I would get 1 point. And if I got both answers, so I had 33.013 and that there were 4 people in line, I have to have both of those, I would get 1 point. And then if I justified it using all this work over here, I would have also gotten that last point. So that was problem 1.